Welcome to Physics World Online College, where we explain physics for you to understand and do very well in your exams. In our class of today, we'll continue in our discussion on projectile. Today, we'll look at the classification of projectile into non-angular projectile and angular or inclined projectile. Now, this non-angular projectile is similar to motion under gravity. Like I told you in the previous class, there's a connection between motion under gravity and projectile or projectile motion. So we'll look at that connection in today's class. Then in our next class, we'll look at angular or inclined projection or projectile. Now, we'll consider this as case 4, non-angular projectile with emphasis on horizontally projected motion. This will be the first time you will come across question where you are told that the body is projected horizontally with a velocity. So you have to take keen note of it. You'll be told the body is thrown horizontally or projected horizontally with a velocity from a height. So once you read that part of the question, your mind should come to horizontal projection or horizontal motion. So let's take this analogy. If you have two coins, coin 1 and coin 2, placed at the edge of a table and the table is struck, both coins will fall down and arrive on the ground at the same time. We have established that time and again. Although one of the coins will jump forward with a certain horizontal velocity, both coins exhibit the principle of projectile. What are we saying? If coin 1 falls under gravity from this height, as coin 2 is thrown or projected with a velocity u subscript s from this same height, that both bodies will strike the ground at the same time. Let me put it this way. If a ball falls freely from rest at the same height that another ball is thrown or projected horizontally, then both balls will strike the ground at the same time. Why is it so? Because they are both living from the same height. Even though coin 1 falls from rest with initial velocity at 0 and coin 2 is projected horizontally, is thrown horizontally with a velocity also at that height, with a velocity that is not 0, with a velocity that is given, with a velocity that is known, with horizontal initial velocity of projection, that both bodies fall to the ground at the same time. That is what we are saying. Now, in this case, the two balls are falling under gravity, and it is only the component, the vertical component, that is influenced or affected by gravity. Their horizontal component is not affected by gravity. Good and fine. So here, we will be expected to look at the time, to find the time it will take the balls to fall to the ground, which is T2. And from our last discussion, we established that T2 is square root of 2h over g. Then we will be asked now to look for the horizontal distance or range. Like I said, this horizontal component is independent of what? Gravity. So the velocity of projection, the horizontal velocity of projection is not zero. And that will be the value of velocity you are given. Now, you use that horizontal velocity to multiply the time it takes the ball to fall to the ground, T2. And that will give us the what? The range or the horizontal distance. Good and fine. So we'll apply it now to solve a particular problem. That's solution to example 4. Solution to example 4. We are told that a tennis ball is projected horizontally from the top of a vertical cliff 40 meters high. Like I said, when you read this type of question and you read thrown horizontally, projected horizontally from a height with a velocity, this one is not for you to say, oh, the velocity at the maximum height is 0. No. That velocity that you are given is the horizontal component of the initial velocity of projection. It is not 0. Good and fine. Like I said, it is the vertical initial velocity that is 0. Uy, that is 0 at the maximum height. The initial horizontal velocity or speed of projection is not 0. That is the one that you are given. So let's put it this way. Let me have a diagram thought. So if you have this as the height, the cliff, with height h given as 40 meters. The height is given as 40 meters. And then you throw the ball with horizontal velocity u subscript s as what? 8 meters per second. I told you that is the velocity. It is from a height, but thrown with a velocity. So it is not 0. Good. You are given gravity. His body is falling down, so it's moving in line with gravity. A is plus g. And that is what? 10 meters per second square. So now we're asked to find the time it takes the body to get to the ground. The time taken to reach the ground. This is small t, T2. That's t down. And we said that is given as square root of 2h over g. We substitute our value. 2 times h, which is 40, divided by g, which is 10. That gives us that T2 is square root of 80 divided by 10, which is square root of 8. And the square root of 8 is 2 root 2, or 2.83 seconds. That is the time it will take the object to what? Get to the ground. T2. Look for it. Then they say find the total time taken, or the time of flight. Once we have gotten the time it takes to get down, we can get the total time, which is the same thing as what? Getting the time it takes to from the ground get up, and from the up gets to the ground. So simply put, the total time taken, which is the time of flight, total time taken, and this is capital T. Please don't confuse the use of the two. Total time taken, capital T, is equals to 2 small t. That is twice the time taken to fall to the ground. And that will give us, capital T is 2 times 2 root 2, which is 4 root 2. And that in decimal will give us 5.66 seconds. Then they say, well, obtain the total time. Then they say, find the vertical component of velocity when the ball hits the ground. Now, the vertical component of the velocity, that is the final maximum vertical velocity, which is this. That is the velocity of the body before it hits the ground, which is maximum. That velocity is influenced by gravity. So, for the vertical part of the motion, this is the vertical initial velocity. Is 0 at the what? Greatest height. As the ball or the coins falls down, that vertical component of velocity begins to increase with gravity, begins to increase with time. It increases, it has a value v1, vy1, but the horizontal velocity is still constant. It increases further, vy2, but the horizontal velocity is still constant. And then it will be a maximum before it hits the ground, which we will get using this formula root 2gh, or g times t2. So for us to obtain, for us to get the time, the velocity, vertical component of velocity, or sometimes they say the velocity with which the body strikes the ground, you know you are looking for what? The Vy max. So option C says the vertical components of the velocity when the ball hits the ground. The vertical component of the velocity before the ball hits the ground, that is V max or Vy max, is given as root 2gh. And if we substitute, we have square root of 2 times 10 times 40. And that will give us square root of what? 800. And the square root of 800, we have the value as 28.28. 28.28 meter per second. That is a maximum velocity, maximum vertical velocity before the ball hit the ground. So your Vy max we have obtained with root 2gh. I said you can also use or Vy max is g times the time it takes to what? Get to the ground. That is 10 times 2.83. And that will also give you approximately 28.3. If you approximate this 8 to 1, it gives you what? 2.83. So we are right, meter per second. Now, lastly, we are asked to find the distance from the foot of the cliff to where the ball hits the ground. That is the horizontal distance or the range. And like I said, this horizontal distance is independent of gravity. It is not affected by gravity. And it is that horizontal distance or range, we use that velocity, that initial horizontal velocity, we use it to obtain that range, which is this, as the horizontal distance here, the range or horizontal distance. So we say option D says the horizontal distance or range is independent of gravity or vertical acceleration. It's independent of gravity or vertical acceleration. And for us to obtain it, we said the range R is the horizontal initial velocity, which is constant, multiplied by the time it takes the body to what? Fall to the ground. So this is the same thing as US dot, the square root of 2h over g. We have already used this, so I don't need to repeat myself. So this horizontal initial velocity of projection 8, this is where we make use of it, multiplied by T2, which we have calculated as what? 2.83 seconds. So when you multiply it, you will have a value of 22.64 meter. So anytime you are asked to find the range or horizontal distance, just use that initial horizontal velocity given to you with which the object is thrown or projected. Use it to multiply the time it takes the body to fall to the ground. You will get the what? The range. Please, I have this classwork or assignment for you to do. Solve it. Post your answer on the comment section. In our next class, we will look at angular or inclined projectile, where angles are now given. In all the equations we have solved so far, you will not see any angle given to you or mentioned. So it is in that case, the next case, case 5, you will see angle given to you, then you know what to do. Please share this class video with your friends. Bye.